Hello everyone, welcome to Roman Just Codes. I'm Roman, and in this episode I'll continue building our Flicky Home Automation app. And finally, we're ready to talk to our smart devices by sending HTTP commands to it and communicate with them from our Flutter app. We first wanted to build the majority of the app and set up a good foundation before we got to this point, and I'll assure you it was worth the wait. Make sure to catch the previous videos in the series so you can catch up, or grab the link to the repo from the description for the full project. Without further ado, let's get right to it. We'll be interacting with the Shelly family of smart plugs in this video. If you want, you can review our first videos in which we demonstrated how we set them up in our network and how we configure them using the companion Shelly app. Go ahead and check that video out and come back to this point, as that step is required. Your devices should be up and running, fully operational, and available on your network in order to complete this tutorial successfully. Once your Shelly smart plugs are connected, let's do some smoke tests using Postman, or even any good old browser should do, as we will be sending HTTP GET commands to it. Really simple. Grab the IP address of the smart plug on your Wi-Fi network and do the following HTTP request. This command toggles the device associated with the IP and channel provided and successfully turns it on or off accordingly. Hit send. If the device is off and you send it the off value, you'll just get a successful JSON giving you the current status, that is still off. You can tell by reading the is on property and check the value. Here is false, so it's off. Change the value to on and hit send. Effectively, you get a true value from the isOn JSON property as expected. So this is exactly what we'll be doing in this video, as a result of the user toggling this button when they are in the device details page. I'm going to go ahead and create another shared services entity called device HTTP service, which will also receive a riverpod ref instance injected via its constructor. I'll create a method called toggleDevice, which receives a device model as an argument and returns a future of type device response. You ask, what's a device response? I haven't created that yet. Let me show you now what this object entails. I'm creating my very own Poto class called device response that will represent the result of toggling a device in my Flicky app. This object will keep track of some simple properties: a message, a status code, and a success flag. Once created, let's pick it up where we left off in the device HTTP service. The rest of the logic will be wrapped inside a try catch where I'll handle a timeout exception, I'll tell you why in a minute, and a catch-all exception block as a fallback. First, I'll retrieve the outlet metadata associated with the outlet ID present in my device model. From there, I'll need the IP and the outlet ID, or what Shelly calls the device channel. Construct a URI using the outlet's IP address, the path called relay / the outlet ID, followed by the query string parameters turn, and depending on whether the device is selected or not, or toggle or not, then send the value off or on respectively, since we're flipping it. I need a way to issue HTTP commands from here, so I'll import Dart's HTTP package. I've used other HTTP packages like Dio in the past, and it's pretty versatile, but remember my theory of keeping things simple and straightforward? The HTTP package serves my purposes well in this case. Let's carry on. So I make the GET request and immediately tack on a timeout of 2 seconds. If the 2 seconds have elapsed with no response from my request, the timeout exception takes over, or for any other exceptions, then the code in the exception block gets executed. For now, I'll just return an instance of my very own device response object. All I care about at this point is whether it's successful or not the status code per se. But if the status code is 200, I'll consider it a success, just like when I trigger this using Postman. With this code in place, let's proceed and create a wrapper provider instance called device HTTP service provider, which encapsulates an instance of our newly created device HTTP service. This only dispatches an instance to our service. We still need a way to handle this as a future. Therefore, we'll create a future provider to which we pass an instance of device model. So let's use the family method, which allows to pass a parameter inside our provider instance as such. This is just a simple logic to check whether the device we are toggling does have an outlet assigned to it. Anything greater or equal to 0 is a valid device outlet ID, so this is enough. If so, make the call to toggle device off of the device HTTP service provider instance and returning the obtained response. Otherwise, consider it a failure and return the corresponding device response. We need an entity to keep track of the toggling and triggering of this functionality in a decoupled way from our UI, so I'll create a view model class called device toggle view model that manages a boolean flag state, true or false, toggle or not. Simple as that. I'm checking here whether the selected device's outlet is a valid one. This may be redundant here, but I'm using it to tripwire the state and immediately get out of the logic without any further calls. Simulate a tiny delay, followed by the actual invocation of our device HTTP service future provider, passing into it the selected device. I'll await on this via its future so we can proceed accordingly. Capture the success flag, and if true, then is when you can proceed to toggle the device on the UI. So we are ensuring that the operation was successful first before reflecting it on the user's screen. Then follow it by truly persisting the updated state in local storage, that way it gets saved and persisted right away. In the device details panel widget, let's get rid of the toggling of the device here. This should be handled as a confirmation of the successful HTTP request, as we did earlier. First, we need a wrapping provider for the device toggle view model as such. Instead of triggering the toggle device method on the device list VM provider, trigger the toggle device on the device toggle VM provider. I'm going to keep track of the toggling internally using a boolean flag called isDeviceSaving. While the device has been toggled plus my simulation delay, I want to disable the capabilities of removing the device, as well as show a progress indicator. This flag is fed from the device toggle VM provider. I'll refactor now the logic here, so instead of just showing the toggle button always, when the isDeviceSaving flag is true, I'll show a circular progress indicator, and when it's done saving, we'll show the toggle button back with its updated state, since we will ensure that the saving occurred whether it was successful or not. As mentioned, we should only allow removing of a device when the device is not toggled on and is not in the process of being saved. So add that to the enabling logic here. And now for the moment of truth. Toggle the device from the UI. Let's confirm via Postman. Toggle it on. Things are looking great. Let's fix this cosmetic issue here where the UI is jumping a bit when the toggling is happening. I'll wrap this whole logic inside another expanded widget, that way both regions split the available space accordingly. Now it looks much cleaner and seamless. Now check this out. I'll toggle it on, and since we're persisting the state in shared preferences as well, let's dismiss the app and see. We should see it still selected or toggled if that's how we left it. Dismiss the app and bring it back up. Sweet, the device persisted the toggle state and seamlessly allows us to pick it up where we were, and you can still interact with it as normal. Let's do some minor cleanup in the loading notification view model. Let's honor the successful completion of all the activities performed and set the state appropriately. Right now, we're always setting the state to success, but we need to collect the result of the previous activities. For example, we're missing to capture the successful loading of the outlet list here. Also, we want to account for the local storage bootstrapping correctly, the loading of the device list, and the outlet list. Let's start with the local storage initialized and the outlet list loaded. We'll add the rest later. Do a short delay, display the appropriate message, whether the result is successful or not, and set the proper state based on this result. And just to test what the behavior will be if one of these fail, let's manipulate one of the results, the loading of the local storage service, and test it again. There it is. It doesn't proceed further because there was an error. You can be more explicit on your messaging to the user, that way they can proceed accordingly, but this is a good start. I'm going to continue adding more validation to the loading logic, so stick around for the next video, which I believe you're going to enjoy. Because since we have most of our app in place and fully functional already, I want to be able to load it on larger screens and be able to deploy it on both phones and tablets around the house. Therefore, in the next video, I'll be dealing with responsive UIs in Flutter, so stay tuned. See you on the next video. Hey there, I am Roman from Roman Just Codes. I hope that you found the content of this video very useful, and if you did, make sure to like it and subscribe to this channel. You know subscribing to this channel is free, right? Thank you so much for watching.